everybody, and welcome to Advantech's System Integration and Interoperability presentation at the ATCA virtual site. My name's Paul Stevens from Advantech, and to situate me in cyberspace, I'm presenting today from Advantech's offices in Paris, France. Well, we've all learned a lot today about how fully pre-configured ATCA systems certainly address a growing market demand. At the same time, many of the Tier 1 OEMs we work with at Advantech continue with their own integration to better control the process and the multiple complexities it involves. They often require extremely close collaboration with building block vendors like ourselves in order to implement custom functions or validate new system rollouts. The key to this is definitely integration teamwork, with sleeves rolled up during the entire system validation phase. My presentation this morning will take a look at the various levels of integration along the ATCA ecosystem value chain and provide an overview of interoperability and testing methods. This will be the first part of the presentation. The second part will take a look at another important aspect of integration, one which facilitates the implementation and rollout of custom functions. The ability to easily add FPGA-based functions with classified intellectual property is an important factor right now for both telecom and non-telecom customers evaluating ATCA. Let's take a quick look at the various integration value levels. Although this may at first seem like a somewhat busy table, it actually takes a rather simplified look at the typical levels of integration in the ATCA value chain. Each integration level has specific design, certification, testing and manufacturing requirements, and it all starts from the lower component level, the bottom here, which basically consists of supplying customers with a kit of components for subassembly, which the customer or system integrator then assembles. The next level comprises the complete subassembly in the form of a fully configured blade or chassis. And at this lower end, the OEM has great opportunities to differentiate from his competition with hardware and software specific to his application. And that particular IP might be some kind of acceleration hardware, encryption or transcoding, for example. And I've tried to draw this box across the bottom of the slide which actually indicates that with customer specific hardware and specialized IP. Now, although Advantech integrates at many different levels, at this sub-assembly stage we find it's important to work closely with the OEM or system integrator to accompany them through customization, through partial redesign, tweaking, and tuning and test as well are very important. So at the system level, let's move up one. The board level sub-assemblies just come together as a complete payload along with the disks, other devices and the various software builds. A lot of time is then invested in overall system integration, test, pre-validation of environmentals, etc., as we make our way through to the famous golden system build, the system which becomes the point of reference for compliance and which is used to test against any later anomalies. On the system integrator's production line, the system needs a special test harness for functionality tests, performance, safety and proper configuration, and the board, software and configuration of the systems are typically subject to revision and a track with serial numbers of each component recorded for traceability. Going up one level, the cabinet level adds multiple systems together with a whole new set of integration procedures as indicated. Pre-staging can also be important for complex network solutions, and global logistics is very often necessary to manage inventory or build a system to order and drop ship it to the final integration site. So the complete integration value chain therefore encompasses many different levels. As we integrate the parts, an important aspect of integration in a commercial off-the-shelf ecosystem is of course interoperability. And this is where industry organizations like PIC-MG and the CPTA play an important role. They alleviate interoperability issues that a system integrator would have to face if there was no common ground on which to test the products. The benefits of a well-defined interoperability at the building block level are shown here. And as you can see, they kick off the healthy knock-on effect from network equipment provider to service provider, as shown here. So now we've spoken about the benefits of having interoperability rules and guidelines, let's take a brief look at where the CPTA fits in. This diagram takes a look from a slightly different angle at the integration value chain, from silicon to building block and to platform vendors, all the way up to network equipment providers, and finally deployment into the data center and the central office environments. At each layer, different hardware and software components need to interact in a controlled manner and in accordance with a set of rules and standards. Well, we all know that in practice standards are always open to interpretation and allow a number of variants in areas such as fabric, system management, cooling and so on that make finally interoperability quite challenging. But at the end of the day, let's face it, what customers really want is certainty that open standards based products from competing suppliers can be integrated into a system and they'll all work together. So after identifying the barriers to interoperability and with a real will to close the gaps, the CPTA decided to focus on thermal interoperability and the shelf management subsystem. The Interoperability Compliance Document, the ICD from CPTA, defines chassis thermal performance, whilst the other focuses on a major source of interoperability issues, which is shelf management. And the group's work has resulted in a development of a test tool, the ATCA or Advanced TCA Manageability Tester, which can be used to test a single blade, a chassis or through, or all the building blocks simultaneously in an integrated system. The CPTA and PICMIG regularly join forces to host an interoperability workshop to test advanced TCA and other components against industry profiles and test suites. And over here in Europe, it's hosted every autumn in Germany, and it's open to members of CPTA and PICMIG, providing a confidential atmosphere for testing, learning and resolving issues. And typically up to 20 companies participate in the event. These efforts have helped to improve interoperability among numerous blades and help the whole industry to realise the benefits of open standards. So they're a great opportunity for manufacturers to test their boards with a wide range of suppliers. And at Advantech, they've been extremely helpful to us. And this slide, just to follow on from the previous one, is just a mashup of some data I gleaned from our R&D team after one of the earlier workshops they attended. And without going into any detail, it's a snapshot of all the AMC's hub boards and chassis which we were able to test with one of our Intel Xeon blades. The important point to retain is that we learn a lot from early interop testing, and it allows the whole ecosystem, including customers, to benefit immensely. Taking a closer look at the manageability side of things and available test suites, CPTA's Manageability Task Force describes an ATCA test tool that tests the enumerated PICMIG ATCA v3.0 requirements. The CPTA Test Procedure Manual, the TPM, has a direct one-to-one mapping correlation with the PICMIG requirements. Now, running the ATCA tester is the best way to claim PICMIG compliance, as it gives the user a very good picture of non-compliance with the specs in the 1 hour long test run. The new tester from Polaris, as approved by the CPTA, is Windows based and has protocol decodes to help a developer see hex dumps and byte errors. At the last ATCA summit, CPTA also introduced a self-testing program to enable companies to perform self-testing and verify product interoperability. Over here at Advantech, we use the test tools all the time. During interoperability discussions with customers and prospects, we are often asked to provide the compliance test reports. Internally, we run compliance testing on every official firmware release we make, and we find there are a lot less interop headaches if the firmware is pre-tested and has fully passed the tool's compliance testing. Next, we'll come back to focus on some of the other aspects to be considered at the subassembly integration level. Down on the ATCA blade level, thermals are important, and the choice of onboard processor, memory, mezzanines and AMC modules can have a significant impact on whether the blade can be powered or cooled. When designing an ATCA solution for the telecom market, ATCA blades need to adhere to the NEBS Level 3 standard. The NEBS environmental standard states that a system must operate in an ambient temperature of 40 degrees C, but can operate in an elevated ambient temperature of 55 degrees C for up to 360 hours per year for systems fan failures. Now, ATCA blades have been typically designed with maximum total blade power of 200 watts to be cooled by 35 cubic feet per minute of air entering the system at a short-term maximum of 55 degrees. And the power budget of 200 watts per blade is pretty good guidance for a typical ATCA system. However, some ATCA chassis can now provide more than 35 CFM, and system power budgets can exceed 200 watts thanks to increased airflow. So 50 CFM can easily cool today a 300 to 400 watt blade, but come with higher costs and acoustics hit, which needs to be addressed early on in the integration, test and validation cycle. Advantech pre-integrates a wide range of standard blade sub-assemblies based on their on fully tested configurations. However, we still work together very closely with our OEM customers during their integration process to ensure that the on-blade configurations comply with their overall chassis thermal solution. Here I've listed in the orange box some of the key services our customers are looking for when they're working with us at the sub-assembly level.